In this video, we'll be covering how to graph transformed cubic functions. Okay? Now, the first thing we want to do is look at our function and try to create a table of values that will help us graph it. So we're going to start first of all by the parent table, which is basically -1, -1, 0, 0, and 1, 1. Remember y equals x to the third power? So if you plug in -1 into x, you will get a -1. You plug in 0, you get 0, and you plug in 1, you get 1. So that in the middle will be the table of the parent function. Now, let's look closer at our transformed function, and let's discuss what the transformations are. And because that will help us fill the x and the y values and find the new points that would be on this graph, okay? So the first thing I can see is that there is a -2. So if there is a negative, if the a is negative, so a is -2, that means there will be a reflection over the x-axis, okay? And there will be a vertical stretch of 2. Since 2 is greater than 1, so there's a vertical stretch of 2. So the first thing you need to do is multiply the y by -2. And now the k is -1. So that means that your graph is going to go down 1 unit. And then after you multiply the y by -2, you have to subtract 1. And why am I doing that to the y? Because as you can see, -2 is outside the parentheses. And -1 is also outside the parentheses. So these two changes are done for the y. And you go from left to right. So the first change is for the a. So you multiply the y by that a, which is -2. And then the second change is the k. So you subtract 1 from the answer that you got. So let's see. -1 times -2, that would be a 2. 0 multiplied by -2, that would be a 0. And 1 times -2, that would be a -2. Now, after you multiply by -2, you have to subtract 1 from this answer. So 2 minus 1 is a 1. 0 minus 1 is a -1. -2 minus 1, that's a -3. So this is going to be your new y value. Okay? Now, let's look at the transformed equation again, and let's find what the transformation is. Now, the second transformation is the h. The h in this case is 1. If the h is 1, that means that your graph moved to the right 1. So that's why we need to add 1 to the x. And why the x? Because the h is inside the parentheses. So you add 1 to the x. So -1 plus 1 is a 0. 0 plus 1 is a 1. 1 plus 1 is a 2. And that would be your new x. Okay? So my new points that are going to be on this transformed graph are going to be 0, 1, 1, -1, and 2, -3. So 0, 1, that's the first point, 1, -1, and 2, -3. So that's how you can find the new points using the transformed table. Is there another method? You bet, and I will show you what the second method is in a minute. Now let's start plotting these points. So 0, 1, that's my first point. 2, -3, that's my second point. And 1, -1. Okay? Now, which one do you think is the point of symmetry? It's the one that's in the middle. So the point of symmetry is going to be, in this case, 1, -1. Now, could I have known that from the beginning? The point of symmetry is going to be hk. The h is 1, and the k is -1. So you can tell what the point of symmetry right from the equation, right from the beginning, okay? Now, the point of symmetry is 1, -1, and that shows on the graph. It's the point in the middle. Now, since this is going to be reflected on the x-axis, the a is negative, so that's going to be a graph that looks like that. Okay? Now, that's my new transformed graph. Now, what would be the other method to solve something like this? Now, so the other method is you find the point of symmetry by looking at the graph, or at the equation, sorry. Now, the point of symmetry is 1, -1, so you start with that. and you plot it, 1, -1. Now look at the A. What's the A? The A is -2. It means I have to go up 2 and then move to the left 1 because it's going to be reflected, and then move down 2 and then to the right 1. And that would be my graph. I call these 2 points my reference points because I find them by starting from the point of symmetry and I go according to the A. If A is 2, it means I go up 2, and since it's negative, it's going to be reflected, so it's going to be on the other side. So I move to the left 1 and then down 2 to the right 1, okay? Now that's how you graph a transformed form. That's the second method, and you can use either method. Now what's the domain and range? Since this is going to continue on forever, it's always going to be all real numbers for both of them. What's the end behavior? This is going to be a little bit different now as x tends to plus infinity. So look at the right side of the graph. It's going down the right side, so it's y going to negative infinity. Now as x tends to negative infinity, let me fix the x. Now look at the left of the graph. The utmost left of the graph is going up, so the y will be going to plus infinity. Okay? Now is this odd, even, or neither? Now look at the point of symmetry. Is it the origin? No, it's 1, -1, so it's neither. It's neither odd nor even. And it's not even because it's not reflected over the y-axis. It's not like a U shape, okay? Actually, I've done that. So it's not a U shape, okay? Now this is how you graph. Now I would like you to take a minute and try to graph the second one. What's the point of symmetry? It's -3, 4. You can know that right away. So I'm going to start with the second method first, and then I'll show you how the table can help me decide whether I'm doing the right thing or not. Now it's always good to know 2 methods in case you forgot one of them. And I don't want you to just depend on counting because sometimes you forget. So -3, 4, that's my point of symmetry. That's my H and that's my K. Now the A, or the B in this case, it's a little bit different. The B is half. There's no A. And why did I say there's a B? Because it's inside the parentheses, okay? Now, yes, you can use that using counting as well, but this time you count sideways. So for me to help you understand that better, let's fill the table first, and then we can decide what the counting method is, okay? So let's start with the parent table, which is -1, -1, 0, 0, and 1, 1. Now let's look at the changes that are done to the y. There's no A. The K is 4. So that means that your graph moved up 4. So I need to add a 4 to the y. So -1 plus 4, that's a 3. 0 plus 4, that's a 4. And 1 plus 4, that's a 5. Okay? Now that's the only change that's done to the y. Now if you look at the inside the parentheses, we have a B. So B is half, remember? It's 1. So the inside, if you think of the general transformed form, y equals 1 over b, x minus h to the power 3 plus k. So the b is going to be the reciprocal of the point, so that the b is half. And that means that you have a horizontal compress, or compression, by half. So you have to multiply the x by half, and then the h is -3, which means that my graph is going to the left 3, and we're going to check that in a minute. So first of all, I need to multiply the x by half, so always take the reciprocal of the number inside the parentheses, and then the opposite of the h, okay? So -1 times half, that's a -half. 0 times half, that's a 0. 1 times half, that's a half. And then I need to subtract a 3, so -half minus 3, that's a -3.5. Now 0 minus 3, that's a -3, and then half minus 3, that's a -2.5. So let's go ahead and plot those points, and the points will help me figure out what the pattern is, okay? So remember, those are all crossed out. So my new x is -3.5, and my new y for that x is 3. So -3.5, and then a 3, and then I have negative 3, 4. I already know that from before. That's the point of symmetry. And negative 2.5, and then a 5. And it's a positive function, as you can see, so you connect them as such, always. Now, so what's the pattern? If you have the A, like in the first part, you start from the point of symmetry and you count upward or downward, okay? Upward to the right if it's positive, and then upward to the left if it's negative. Now the B, you count right or left, sideways, okay? So the B is half, so from the point of symmetry you count half sideways, okay? And then up 1, and then half sideways, and then down 1, okay? Now the domain, just like before, it's all real numbers, and the range is all real numbers. The end behavior, let's see what happens on the right as x tends to infinity. So on the right it's going up, so y goes to plus infinity. As x tends to negative infinity, let's look at the left of the graph, it's going down, so y goes to negative infinity. Is it odd, even, or neither? The point of symmetry is not the origin, so it cannot be odd. It's not reflective about the y-axis, so it's not even, so it's neither. Okay? Now this is how you graph if you have the A and the B. So remember A, you go upward or downward. If you have the B, remember to take the reciprocal and you count sideways. Or you can use the table, whatever method you like more. Now in this second problem, they are given us, the graph is given, and I need to figure out the equation. Now let's look at this graph. What's the point of symmetry? 2, 1. So if I know that the point of symmetry is 2, 1, then I know that my h is 2 and my k is 1. Now I need to decide whether it's an A or a B. I will be giving you the form all the time, but if you want to look closer, as you can see, from the point of symmetry, I'm counting upward, 1, 2, 3, so that's an A. I'm counting downward also 3, so that's the A. The A is 3. So my equation is going to be 3 for the A, and then x minus the h to the power 3, and then plus the k. Okay? Now let's move on to the next part. Now this looks more like, if you want to continue that, going upward and downward, okay? Now this looks more like a B, but I will be giving you the general form, okay? But if you count sideways, you will see that 1, 2, 3, 4, and 1, 2, 3, 4, so the B is 4, okay? So remember to always take the reciprocal, and then x, what's the h? The point of symmetry is 1, negative 1, so h is 1 and k is negative 1. So remember, always take the opposite of h. So that's going to be minus 1, and that's all to the power 3. And then plus k, and the k is negative 1 in this case. And that's how you find the equation from the graph. I hope this video was helpful. Make sure that you do the practice sheet.